Good morning, everybody, or good afternoon. Um, Today we're going to start looking at topic 8. First thing we're going to be focusing on are climate factors. Okay, this is on page 384 of your textbook, so I'll give you a minute to get that, or if you need to, just pause the video and go grab it. Okay, good. So first thing I'm going to do is I'm going to be going over some vocabulary with you guys. And we'll be going through the book and looking at different diagrams. And after the completion of this video, you will be uploading your work from the lesson one check. That's usually those pages that I would give you for homework. When you are done with that, you'll be uploading it to the upload discussion post that I will be putting on Schoology. Please, if you can, I think the best method would be to type your answers in a Word document and then simply just upload that document. If you're unable to upload or having problems with that, I would maybe just type it in a Word document and then copy paste it if you needed to into the comment section. I'm just trying to get away from taking pictures of your book because I know a lot of people were having problems with that or it wasn't turning out really good. I know people have different things that they need to use for that, so I understand. I'm trying to make it as simple as possible here. All right. So first thing we're going to be looking at are factors that affect temperature, and we'll be looking at exactly what a climate is. Now, if I asked you what the climate was around where you live, how would you describe that? Um, and this is where a lot of people, including myself sometimes even, we don't think there's a difference between climate and weather, when really there is. They're really two kind of different things. Now, if we're looking at, for instance, climate right here, a long-term weather pattern in an area. So this would be basically the accumulation of all the different types of weather you might have in an area over the entire year. So on a yearly basis, or how it is for an extended period of time, I mean, I'm talking decades, hundreds of years, thousands of years, you know, as long as that area is generally unchanged, what would the climate be? When we're talking about things like weather, okay, we're talking about on a day-to-day basis. While it might be raining today, which has been doing a lot of, it might not be raining tomorrow. So today might be very wet, while tomorrow might be very dry. Today might be very cold, while tomorrow might be generally pretty warm. When you take all of that and average together, you get a climate. So basically, your climate is the average. Sorry for my handwriting. I'm using the computer here on a stylus pen, so it's not great. I'm doing my best here. Is the average of all the weather. Okay, not just what it is day to day. All right, and you're probably going to see me write a lot of random lines on here because I got to keep switching the. Okay. All right, if you turn to the next page, page 386. All right, they're talking about all right different types of temperature zones. Okay, so if we look at the extremes, okay, very northern part of the world, right, the North Pole and the South Pole are going to have a polar temperature zone. Okay, polar just like the North Pole and the South Pole. All right, these are the extremes. These are very cold. Okay, then we're going to have the other extreme. Okay, tropics, the tropical. All right, tropical zones very hot. Okay, so we're going to have very cold temperatures at the polar regions, very hot temperatures at the tropical regions. Notice the tropical regions are right along this line that goes straight through, kind of east to west, right, known as the equator. Okay, now we have one type of zone left. Right, we have our temperate zone. Okay, in our temperate zone, right, temperate kind of means, like, if you want to think of it as moderate. It's not too hot, it's not too cold. Okay, so it's like right in the middle temperature wise. Okay, some areas might be hotter and colder than others, but you're not going to get those extreme hots and those extreme colds. In the polar regions and the tropical regions, all right, generally the tropical regions are hot all year long, and the polar regions are generally cold all year long. In our temperate regions, okay, going from here to here and here to here, okay, we're going to have more temperature swings. Have a cold season, a hot season, and then maybe fall and spring, which are generally in between those two. Okay. All right. Next page. All right. So now we're talking about ocean currents. Okay. When we're talking about ocean currents, we're talking about the flow of the ocean water in big waves. We're not just talking about little waves and tides and things like that. We're talking about these massive ocean currents that are traveling all over the globe. Okay. Now, when we're talking about how water, and then after this, when we talk about air, how those things travel, we get those major wind patterns, major ocean currents. That's going to have to do with how hot and how cold the water is. Okay, so if you're looking at this diagram here, um, and if you did your reading, it'll say here that generally we're ocean water is it's always going to want to go to where the opposite of it is. So if I have really warm water, it's generally going to end up traveling to a place that's colder. And if I have colder water, it's generally going to travel to a place that's warmer. And you can kind of see this in this diagram here. So if I have, for instance, right here, okay, I have very warm water, right, which is marked with the red, right, traveling up from where the equator is, right? So here's the equator, right? That's generally the hottest place on the planet. All right, so that water is going to warm up and it's traveling northward, closer to where it's cold. So we have hot down here, cold way up here. And as that water cools, now that cool water is going to travel in the opposite direction. And it's going to travel back down towards the equator where it's going to warm back up. Okay? You can also see the same here. We have, right here, we have cool water traveling up towards the equator and warm water traveling back down to the south, towards the South Pole, where it's colder. Okay, so warm wants to travel to a cold place, cold water wants to travel to a warm place. All right, so next, I'm on the next page now, page 388. We're going to be looking at air movement, so prevailing winds. We just talked about ocean currents. Now we're going to look at what makes these major air masses move across the globe. And it's pretty much the same thing we just talked about with ocean currents, the same kind of mechanism. So if we're looking here at, let's look at this part of the diagram right here. I have this warm air, okay, this hot air starting right here, okay, and as it air warms up, it's going to rise further off of the planet. So this is actually going up into the atmosphere. Okay? And as the air rises up, it starts to cool down. All right, so what did we talk about when things are, when, for instance, when water was warm, Where did it want to move? All right, it wanted to move where it was cooler. So now I have this warm air up top, right, and it's starting to cool, right? And as it starts to cool, I mean, it's still warm, but as it starts to cool, okay, it not only is that warm air trying to move north away from the equator, I remember the equator is right here. It not only is it trying to move north away from the equator, but as it cools down, it's also dropping back down to the planet, right? Back down to the surface, where it will start to warm up again, right? So remember, right now it's still cool. It's still cooler than it was here. So that cooler air is, as it's warming, is traveling across the surface of the Earth towards where it's warmer, and then as it gets to its peak warmness, it's going to travel back up again, and the cycle continues. Now, the opposite could be said for this section right here. It's doing the same thing, but moving in a different direction. We have air that has risen up that's warm, traveling back towards the equator, but downwards, all right, because it's getting cooler. And then as it warms up across the surface, all right, so it's cool here, the cool air is traveling. I'm sorry, I misspoke. The warm air is now that it's warmed up, it's traveling back up towards the poles. All right, it's still warming up because it's right near the surface of the Earth, but it's now in a cooler place. It rises up, cools down, falls back down towards the Earth, where it starts to warm up again. Okay, so now I've moved on to page 390. Let's take a look at this real fast here. We're talking about major climate zones. All right, so if we're looking at the Earth's surface, it's first asking us on this diagram, circle where we live. All right, so if we know we're in New York State, which is on the East Coast, so right here is the United States on the East Coast, and we're on the westernly portion of New York, about right there where I put that dot. Okay, instead of it said circle the area around you live, I put a dot. That's fine. What type of climate exists where you live? All right, so now we're gonna have to go to the page next to it and take a look at the diagram to figure that out. So if we take a look, um, it was actually, then it was a different place here, but it was that color right there. So if we look, that is a humid continental area. So let's go back and take a look and discuss why. So why would that be a temperate, humid place? All right, so it's temperate because it falls within that temperate zone. All right, we're not quite polar. All right, and we're not, all right, tropical. Okay, we're in the temperate zone. Now, why humid? All right, so if we're right here, why would that be humid? Take a look at these. All right, so we have large bodies of water in that area. Even though we don't live anywhere near really the oceans, we're still kind of surrounded by a large body of water. Right? We have all those Great Lakes right there. All right, I just realized that I missed something. Um, so I am back. I'm back on page 389. If you look here, we have warm, moist air carried by the Pacific Ocean, right, traveling this way. Now, a lot of that moistness, all right, that water in the air is going to come down as rain, because when the clouds collect too much moisture, they let it go. As that air travels up towards the mountains, right, a lot of that air is going to become more dense, and we're going to have, I'm trying to draw here, more snow and ice. By the time we get left over here, nothing left, right? This is one way we form deserts. All right, ladies and gentlemen, please make sure to continue on to the lesson one check, complete that, and make sure to upload it. All right, have a great day.